Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So in previous video, we have discussed about the concept of objects in object-oriented programming. So in this video, you're going to see about the concept of classes in OOPS concept. So unveiling object-oriented programming. So welcome to an exploration of object-oriented programming, a powerful paradigm that has shaped modern software development. This presentation will demystify its core concepts and highlight its practical benefits for developers. So presentation agenda is introduction to OOPS, core concepts, benefits of OOPS, design principles, practical applications. So then advanced topics such as patterns and considerations, then some resources. So understanding classes. So the classes is also known as a blueprint of an object. So at the heart of the OOP are classes which serve as blueprints or templates for creating an object. So think of a class as a cookie cutter. It defines the shape and characteristics, but it's not the cookie itself. So classes define attributes, data, properties that objects of that class will possess. So they also define methods such as functions and behavior that objects can perform. Crucially, a class does not occupy memory until an object is instantiated from it. So instantiating objects, the instances. An object is an instance of a class. When you create an object from a class, you are essentially bringing the blueprint to life, giving it concrete existence and memory allocation. So each object has its own unique set of attribute values even if they share the same class definition. Objects interact with each other by calling methods defined in their respective classes. The process of creating an object from a class is called instantiation. So encapsulation, data hiding. Encapsulation is the bundling of data, attributes and methods that operate on the data into a single unit or class. It also restricts direct access to some of an object components, a mechanism known as data hiding. So it provides data security, controlled access, modularity. So protects data security protects internal state of an object from unauthorized external access, preventing accidental modification. Controlled access to data is provided through public methods, getters and setters, ensuring data integrity. So next one is modularity. Makes the code more modular and easier to maintain by isolating changes within a class. So inheritance, building an existing code. So inheritance allows a class, subclass or a derived class to inherit properties and behaviors from another class, superclass or base class. This promotes code reuse. It promotes code reuse and establish a natural hierarchy. So parent class, define common attributes and methods serving as a base for specialized classes. In child class, extend the parent class, inheriting its features and adding unique functionalities. Next one is code reusability. So reduce the redundancy by allowing new classes to build upon existing tested code. Hierarchical structure models real world relationship and creates a clear organized class structure. So next concept is a polymorphism. Polymorphism means many forms. So poly means many, morphism means taking a form. another form. So polymorphism meanings many forms allows object of different classes to be treated as object of a common superclass. It enables a single interface to represent different underlying forms. So it consists of two methods. One is method overriding and one is method overloading. So it has a dynamic polymorphism and runtime polymorphism. So in method overriding, subclasses can provide specific implementation for methods defined in their superclass. So in method overloading, a subclass can have multiple methods with the same name but different parameters. So this concept simplifies code by allowing generic operations that behave differently based on the object actual type at runtime. So the key takeaways and next steps are, so OOP is a foundational paradigm for building robust, scalable and maintainable software systems. So mastering these concepts is crucial for any modern developer. So practical regularity. So implement small OOP project to solidify your understanding of classes, objects and core principle. Explore design patterns. Investigate common OOP design patterns, example singleton, factory, to solve recurring design problems. Learn a language. So dive deeper into an OOP language such as like a Java, Python, C++ or C# to see these concepts in action. Thank you.